Lesson 6.9, multiplication of decimals. Our objective today will be to learn two strategies for solving decimal multiplication problems. We'll be able to understand the placement value system, and we will be able to perform operations with multi-digit whole numbers and with decimals to the hundredths. Our warm-up is to explain how the placement of the decimal point in the first factor will change and then evaluate it. So you have 3 7/10 times 10 to the third power, or 10 cubed, and you have 805 divided by 10 to the third power, or 10 cubed. So you have one multiplication and one division. So take a look at those. How would your decimal point change in the very first factor? So if we look at 3.7, 10 times 10, times 10, we know times means our number is going to get larger. So when you're looking at a problem like this, we're going to take that decimal place and we can look at that exponent and we can see that we're going to move it 1, 2, 3. And if I rewrite it over here so we can see it better, it goes 1, 2, 3. That's where I'm going to put my placement of the decimal and put zeros in those. And we see that we turn 3 7/10 into 3,700. Now with 805 divided by 10 cubed, we need to realize and remember, where is the decimal? Because I don't even see it. Remember that we can put a decimal right here. You can add zeros and that number stays the same. So our decimal is right after the 5. And we know that when we divide, our number is going to get smaller. That means our decimal is going to move to the left. So I'm going to take it 1, 2, 3. And now we have created 0 and 805 thousandths. That should just be a refresher of what the multiplication means with an exponent of power of 10 and what dividing with the power of 10. So if you can open up to page 219 and look at the problem that is at the top, and go ahead and pause the video now, solve it. When you finished it, come back and let's look through this together. So hopefully you had some solutions, you weren't stuck, but some strategies for that problem would be as follows. Let's take a look at these together. You could have used repeated addition to solve adding 1 2/10 8 times. So you could have done 1 2/10 plus 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 1 2/10. And you could have found out that that was 9 6/10, 9.6. You could have also, here we go. You could have multiplied the whole number part of the decimal, 1 by 8 for a product of 8. So 1 times 8. And then you could have added all the 2/10 8 times. So then you would have come up with 2/10 plus 2/10, 2/10, 2/10, 2/10, 2/10, 2/10, 2/10, and you would have gotten 1 6/10. So you had a kind of partial addition. So you've added the whole numbers, added the decimals, and then you would have added those two together, getting 8 plus 1 6/10, coming to a total still of 9 6/10. So the math message here, it says Tori has 8 blocks. Each block is 1 2/10 centimeters high. If Tori stacks the blocks, what will the height of the stack be? How could we estimate for 1 2/10 times 8? What kind of estimation could we do here? Because we're working with a decimal. If I'm looking at 1 2/10, I might round it to 1 and round that to 10 with a 10 being there. Or maybe I left the 8 the same and I get 8. So I'm looking at my estimation here and I'm seeing that my answer should be somewhere between 8 and 10. 8 and 10. Hopefully you agree with me. So the answer of 9.6 that we got by possibly doing repeated addition Does it make sense with that estimate? Does it make sense? Does it fall in that category of between 8 and 10? Is it logical? To me, it is, because I said earlier that if I did 1 times 8 and I'd get 8, and if I did 1 times 10, I'd get 10. 9.6 is right in there. It's right in between 8 and 10. So today we're going to develop strategies for multiplying decimals that are based on what you know about whole number multiplication, estimation, and powers of 10. So you can see at the top here, we've got 110 times 2.8. That equals 308. If we take 11 times 0 and 28 hundredths, we get 3 and 8 hundredths. And then if we take 11 times 2 and 8 tenths, we get 30 and 8 tenths. In a previous lesson, you solved these problems and you observed that both of the factors and products have the same digits in the exact same order. We go 1, 1, 0, 2, 8. Notice that the 0 is just missing in this one because it's not needed. They differ only in where the decimal point is placed. That's the only difference in them. Take a calculator. Remember, you can have it in your hand or you can have it on Google or it's just embedded into your Chromebook or laptop, and solve each of these problems. 1 and 2 tenths times 8 tenths. 1 and 2 tenths times 8. And then 12 times 8. Pause the video if you need to. What do you notice about the factors in all three of these problems? Hopefully, you're noticing that they do the same thing as we did here. They're doing the same thing here. We go 1, 2, 0, 8, 1, 2, 8, 1, 2, 8. The 0 is just missing because it's not needed in the second two. Do you think that this pattern is true for all multiplication problems with factors that have same digits in the same order? We just saw what happened a second time. I want you to test the pattern by writing down 3 multiplication problems on your own with factors that have the same digits in the same order, but throw in a decimal point in different places. So like we did here. Okay. Try it out. Test it. Oh, not this one. This one. I thought I showed the same thing more than once. So try it out. And then come back. Test it. And hopefully you found, sorry for that long pause, hopefully you found that this pattern is true for all multiplication problems. One strategy for solving decimal multiplication problems is to multiply the decimals as if they were whole numbers and then use your estimate to help place your decimal point. For example, 6 and 8 tenths times 2 and 1 tenth. Let's check through these steps here. There's 3 steps we're going to look at. First step, make an estimate. Okay, so our estimate here, when I'm looking at this, estimate, I'm going to turn this to a 7. 6.8, that's going to round up to 7. 2.1, I'm going to round it to 2. 7 times 2 is 14. There is my first step. Then I'm going to multiply as if the factors were whole numbers. So I'm going to ignore the decimal. So let me change the color here so you can see my next step. So this is going to go with step 2. I'm going to do 68 times 21. I know that 8 times 1, 8, and 6. I'm going to a new place value, so I'm going to put that 0. And so then you'll see my thinking here. So we've got 8, 12, 4, and 1. So here I get 1428. I would think of that as 1,428. But I do remember that I made an estimate of 14. So I'm going to use that estimate to help me place my decimal point. So if I'm looking at this, and I'm thinking, all right, where would I put a decimal in 14? I know my decimal would go right here. So I'm going to put my decimal right here. So that tells me that 6 and 8 tenths times 2 and 1 tenth actually equals 14 and 28 hundredths, 14.28. You can check it with a calculator then, and hopefully you're going to see you get the exact same answer. Remember, it's important to estimate when you're using this strategy because without an estimate, you're not going to know where to place the decimal point after you've multiplied the factors. Estimate is a huge step in this strategy. So look at page 219 and complete all the problems on this page. So it says, for problems 1 through 3, use this following method. Make your estimate, multiply as if they're whole numbers, and use your estimate to place the decimal. Go through problems 1 through 3, go try them out, pause your video, and then come back and check your work with me when you're done. All right. Number 1, a sample estimate would be 75 times 10, and you get 750. You could have even done 76 times 10 and got 760. That still tells you that your number is going to be in the hundreds. And once you multiply 761 times 96, you would have gotten an answer of 73,056. But our estimate tells us it should be in the hundreds, and it tells you to put it right here between the 0 and the 5, right there. Number 2, an estimate, an example or a sample one would be 200 times 2, 400. Again, you could have done 190 times 2. It's whatever you come up with for your estimate. This seems to be the easiest one, 200 times 2. But when you actually multiply 1,896 times 175, you would have gotten 3,318. But our estimate of 400 tells us that my decimal needs to go right here, giving me an answer in the hundreds, 331 and 8 tenths. And problem number 3, a sample estimate would be 6 times 1, because we can see these, that's what these each would round up to, giving us an estimate of 6. If we actually multiply 56 times 8, we get 448. But my estimate of 6 tells me it needs to be in the ones place. So right here is where I would put my decimal, right between the 4 and the 4. There are times when making an estimate is not very helpful or practical, and it's a problem like this, where both of these would round to 0, and we know that our answer is not going to be actually 0, and that doesn't help me. It doesn't help me know, is my decimal going to go in the hundredths place? Is it going to go in the thousandths place? So would you expect the product to be greater than or less than 0 and 73 thousandths here? And why would you expect that? Would you expect greater than or less than? Remember that in the last problem, we ignored the decimal and multiplied as if both factors were whole numbers. So here, I would multiply 73 times 2. So I want you to think about in both of these, how many places and in what direction did we move the decimal point? So for here, we moved the decimal point 1, 2, 3 places. Here, we moved it 1, 2. So you can see that right here. This is what we actually do when we're turning them into whole numbers. So 73 times 2 is 146. So remember, we didn't estimate, because with this problem, we can't use the estimate. estimation to determine the placement of the decimal point because they would have been 0. That would have been our estimate. Instead, what we will do is undo the changes we made to make the factor's whole number. So if we take a look here at these little bits of information, when we changed 7,300 to 73, we multiplied it by 10 to the third. Key is multiplied. How could we undo that? What are we going to do to undo multiplication? What do you think? And when we changed 2/100ths to 2, we multiplied by 10 to the second power. How can we undo that one? What would we do to take back that multiplication? I'm hoping you're saying division because that's the opposite. And I would hope you would find 5 because when we see here, whoops, wrong one. We see here we did 3 and we did 2. So we did 5 places total. And so we would move the decimal place back 5 places. So we would take it from 146, move it 1, 2, 3, 4, 5. And we see we've got 2 little spots that need a 0. And that would turn us into this number right here, 0.00146. So summarizing our steps for that one, the first step, we would multiply both factors by a power of 10 to make them whole numbers, because that's what we know to do. We know how to do the whole numbers. You keep track of both powers of 10 or the total number of places to the decimal point shifted. And so you see you shifted it 3 times and you shifted it 2, giving us a total of 5. You multiply those whole numbers and then you undo the multiplication. You take up how many times did you move the decimal and you divide it. You move it back to the left. So let's do this example here using the exact same strategy. 12.6 times 2.75. Yes, we could do an estimate, but let's practice not doing it. Let's take 126 times 275. Hopefully you're checking my work as I do it. 14, 15, 16, 17, 18. And then we have an 8 there. And we're going over not 1, but 2 place values to get over to the 2. 2 times 6, 12. 5, and 2. So now I can see 0, 5, 16. I hope I wrote that the right way. That shows you got to be neat with your work. Okay, so I've got the numbers 3, 4, 6, 5, 0. 3, 4, 6, 5, 0. I moved this decimal 1 place to the right, and then I moved this one 1, 2. So I've got a 1 and a 2. So I'm going to divide this by 10 to the third power. So using that same method, I'm going to put it here, and I'm going to go 1, 2, 3. Boom. So my actual answer is 34.650. And if I were to do an estimate, like we know we can with this one, 13 times 3 would equal 39. And if we did 13 times 2 would be 26. And 34.650 falls within. It falls within 26 to 39. Excuse me. 220 in your math journal. Let's do some work with that. So for problems 1 through 3 on page 220, you're going to use this method. Remember, step 1, multiply both factors by a power of 10 to make them whole numbers. Multiply the whole numbers, and then undo that multiplication by powers of 10 by dividing the product by the same power of 10. So number 1, you see here, they've got the 2 parts for you. They've got everything listed out to help you get through these steps. Pause the video, work on 1 through 3, and then come back. Let's check over these. Okay, number 1, we should have taken 76.1 times 10 to the first power to get 761. And then you would have taken 9.6 times 10 to the first power to get 96. That answer was 73,056. But undoing, we see we have 1, 2. So you can see that they move the decimal right here between the 0 and the 5, giving us 730 and 56 hundredths. Number 2, we should have multiplied 189 and 6/10 times 10 to the power of 1, giving us 1,896. 1 and 75 hundredths was multiplied by 10 to the second power to give us 175. When we multiply those 2 whole numbers together, you get a huge number of 331,800. But undoing that by dividing by 10 to the third power, that brings us back 1, 2, 3. And notice they dropped the zeros at the end. We didn't need it. You could have written 331.800, but those 2 zeros at the end are not necessary. And number 3, 5 and 6/10 should have been multiplied by 10 to the first power to give us 56. 8/10 times 10 to the first power to give us 8. 56 times 8 is 448. We undo it by dividing by 10 to the power of 2. Whoop, whoop, give us 4 and 48 hundredths. Oops, didn't need that. That is the end of 6.9. There was a lot of slides, but only 6 problems in your math journal to do. Remember, today we talked about 2 strategies for solving decimal multiplication problems. One was using an estimate, and one was using powers of 10. We continued to work on that place value system, and we did perform operations with multi-digit whole numbers and with decimals to the hundredths.